Blitzer 5.5, Trigonometric Equations. So today we're going to be looking at solving equations. They give some basic hints on page 585 in Blitzer. They talk about how you want to isolate the trig function, and then you want to try to figure out all the different places where you could get that certain trig ratio. So I want you to first think, though, about how, well, let's just go ahead and start solving, and then we'll look at how this is different from what we've been doing before. So I'm going to grab a pen. So I've got 5 sine x equals 3 sine x plus square root of 3. And I want to subtract 3 sine x on both sides, which I didn't really need to show, but here we are. So 2 sine x equals square root of 3. Divide both sides by 2. And I have sine x equals square root of 3 over 2. So this is different than before. This is different from just having the sine inverse of square root of 3 over 2. So I know that when I do this, I get exactly one answer. And that's not what we're doing in this case. So it's not okay to have an input and have more than one answer. That's weird in math, right? If my input is my square root of 3 over 2, but my output could be 60 degrees or it could be 120 degrees, we don't like that in math. So we have to have exactly one answer. We have to restrict that. But when I know my answer square root of 3 over 2, there could be tons of different things that give me that answer. So it's just a different mindset. So this is going to be one answer, and these are going to yield multiple solutions. So I need to think of everywhere that my sine could be square root of 3 over 2. So one of them would be over here in quadrant 1, square root of 3 for my y side, 2 for my r side, and then here's a 1. That would be 60 degrees or pi over 3. And then my sine could also be positive in quadrant 2, which is another pi over 3 inside, or 2 pi over 3 in standard position. And so if I take the sine of pi over 3, or if I take the sine of 2 pi over 3, I get square root of 3 over 2. But I also need to think about the period. I could go all the way around this circle, and I could stop here again, and I would still have another angle that looks exactly the same when I draw it out and would give me the same sign. And so we need to say that x is equal to pi over 3 plus multiples of my period. And we know that multiples of the period would be something times 2 pi. So I'll write, usually they write 2n pi. A lot of times I write 2 pi n just because I'm used to seeing it that way. You know, I'm thinking about that period as being 2 pi, and then I'm multiplying it by n. And then we could also have this other one, 2 pi over 3. And then again, that we could have multiples of that as well. So plus 2 pi n. So when they don't give you any kind of, a lot of times they'll say, like, give your answers between 0 and 2 pi. And then you'll know to kind of restrict that down. And we don't write the plus 2 pi n. But here it doesn't tell me that. So I need to give all the solutions. So I need to think about multiples of pi. So in the next one, we're looking at solving equations with multiple angles. So multiple angles means that I don't have just a tangent of x, I have a 2x here. So I am looking at solving tangent of 2x equals square root of 3. So first, I just want to think about where my tangent is square root of 3 over 1. I'm not worried about the 2x part. And we know that there would be multiple spots within this entire unit circle, but the period of tangent is pi. And so I'm only going to worry about between 0 and pi. Everything else is going to be a multiple of that. And I'm going to be able to find them by adding multiples of my period. So my y side is square root of 3. My r side's 1. Or sorry, my x side's 1. My r is 2. So it's the same angle we just looked at, pi over 3. So I'm going to say that 2x equals pi over 3 plus multiples of pi. So plus n times pi. So now what we want to think about is to get x by itself, I have to go through and divide everything by 2. So I divide by 2, x is by itself. If I have pi over 3, but I'm dividing that by 2, now I have pi over 6. And I want to now take my period and divide that by 2 as well. So now I have n times pi over 2. Pi over 2 times n would have been nicer, but that's okay. So I want my answer to be between 0 and 2 pi. So I'm going to keep adding that period until I get all my answers. So like my first answer is pi over 6, and then I want to think about, well, what about when n equals 1? So now I have pi over 6 plus 1 times n over 2, or sorry, n times pi over 2. So 1 times pi over 2, which is just pi over 2. And then I want to have common denominators, so 3 pi over 6. That's going to be 4 pi over 6 or 2 pi over 3. Okay, now what about if n equals 2? Will that give me another solution? So that's going to be pi over 6 plus 2 times pi over 2. So that would just be plus pi. So pi over 6 plus 6 pi over 6. So 7 pi over 6 would be another answer. Remember, I have to be between 0 and 2 pi. 7 pi over 6 is definitely not. 2 pi would be like 12 pi over 6, right? So I have more room. So now I want to look at n equals 3. So I'll have pi over 6 plus 3 times pi over 2. So let's see, pi over 6 plus, if this is 3 pi over 6, that would be 9 pi over 6. So I get 10 pi over 6, which is 5 pi over 3. Okay, and now what about if n equals 4? N equals 4 means I'm going to have pi over 6 plus 4 times pi over 2, which is pi over 6 plus 2 pi. Well, if I'm adding 2 pi, I'm going to be out of that range already. So that is not going to be a solution. So my solutions here for x, and I don't even know where to put them. Maybe we just work down here. So my x could then be pi over 6. That was the one I found. 2 pi over 3, 7 pi over 6, or 5 pi over 3. So I get 4 answers. So I would have had 2 just on this unit circle. And then each of those would have given me one more answer again. And so really, when I had tangent of 2x, if you think about what happens with that period, how it was shortened up, it really doubled my answers. So we're going to look at a multiple angle again. This time we have x over 3. And so my sine of x over 3 equals 1/2. That means I'm looking for where my sine is 1/2. That's what we're worried about for now. So let's see, now that would be over here, 1/2, and also in quadrant 2, 1/2, which is a 60-degree angle, or pi over 6. So that means this one would be a 5 pi over 6. So we've got our 2 angles there. So x over 3 is going to equal pi over 6, or x over 3 is going to equal 5 pi over 6. And then remember, we're going to have multiples of those, right? Plus 2 pi n. So here I want to go through and multiply everything by 3. So 3 pi over 6, because I'm dividing by 3, I got to multiply by 3, plus 2 pi times 3 would be 6 pi n. And then my second one, x over 3, oh, got to multiply that one by 3 also. Eraser. So when I multiply by 3, now I have x. 5 times 3 would be 15 pi over 6 plus 6 pi n. So let's just think about these answers a little bit here. I know that 12 pi over 6 is already 2 pi. This answer is too big. 15 pi over 6 is greater than 2 pi. So that answer is already out of my range. So my other answer, 3 pi over 6, would just be pi over 2. I can't add multiples of 6 pi. It would be out of that domain. They want to restrict the domain from 0 to 2 pi. So that's going to be my only solution on this one. I think it's really tricky when I talk about a range of values. I don't actually mean a range, which is your y. This is really our domain. So that's just an example of how math needs to be super specific, right? So these are all too big. My only solution here is going to be pi over 2. So the example 4 is when we look at having a trigonometric equation in quadratic form. So here I have 2 times something being squared minus 3 times that same thing plus a constant. So it makes me think about factoring. And they're giving me an interval again from 0 to 2 pi for my answers for x. So think about how if this was 2w squared minus 3w plus 1 equals 0. I would be able to right away factor and solve that. And that's what I want to do here. I can factor with a sign. So I know I'm going to set up my parentheses. I'm going to have 2 sine x in one of them. And in the other one, I'll have sine x, because 2 sine x times sine x would be a 2 sine x squared. Because my middle term is minus, but the last one's 1, they need to both be minus 1. And then I just want to check it. This would give me a minus 2 sine x, a minus 1 sine x, so I'm good to go. So now I need to go ahead and solve with zero product property. So 2 sine x minus 1 equals 0, and sine x minus 1 equals 0. So it's 2 sine x equals 1. Sine x equals 1/2. And on the next one, add 1 on both sides, so sine x equals 1. So because I'm only solving from 0 to 2 pi, and the x's are just by themselves, I don't need to worry now about adding multiples of the period or doing any of that. I really need to do that when it's a multiple angle problem. But this is just an x. I don't have a 2x. I don't have a 3x, so I'm not going to end up having those multiple solutions. So I'm going to go ahead and draw out sine x equals 1. That means my y is 1, my r is 1, and my x is 0. So this one's only going to be here at 90 degrees, which is pi over 2. And when sine is 1/2, I already drew that one out, but I'll draw it again. So I get pi over 6. And then this would be 5 pi over 6. So I get my angles. X is going to be pi over 6 or pi over 2 or 5 pi over 6. So I've just tried to put my answers in order here. If you don't do that, it is the least of my worries at this point. What I'm really worried about is a picture and a correct answer. So we're going to do one more today for this first part on our notes. This is using factoring to separate different functions. So sometimes we're going to have to factor. And if I'm thinking about factoring and doing zero product property, I definitely need to have a 0 on one side. So I am going to subtract tangent x on both sides. And I can't just subtract it from sine x because these two are being multiplied, so it doesn't do that. What I end up with is sine x tangent x minus tangent x equals 0. So I do notice, like, I have a term here, I have another term here. They both have a tangent of x, and so I can factor out tangent of x, and then I'm going to have sine x minus 1. So now that I have this factored, I can go ahead and solve a zero product property again. So either tangent x equals 0, or my sine x minus 1 equals 0, which means sine x equals 1. So if my sine x equals 1, that means I've got a 1 over 1, my y and my r are 1, my x is 0. For tangent to be 0, remember tangent is y over x, So I would have a y over 1 or a 0y over a negative 1x. So there's different ways of getting that. So let's think about where this would happen. And again, I don't have to add any multiples because if I'm looking on my entire unit circle, I'm taking care of the 0 to 2 pi. So let's see. When y is 0 and x is 1, that would be right here. 0, 1, and then this would be a 0, negative 1, and that's going to be pi. And then over here for sine, when my sine is 1, that's going to be at pi over 2 again. So that's going to be 0, 1. So then my solutions are going to be x equals 0, pi over 2, and pi. And again, I kind of hopped back and forth between these two drawings to put those answers in order. So we're going to worry about using an identity to solve a trig equation in part 2.